Okay, so for 10.14 we have to display the prime numbers. Write a program that displays all the prime numbers less than 120 in decreasing order. Use the StackOfIntegers class to store the prime. Okay. So the book is telling us to use StackOfIntegers class, and the book gives us the StackOfIntegers class up there. And you just put in its header file and its CPP file appropriately, and you'll be able to use it. Also, make sure you add the header file before you use this class, or else you won't be able to use it. That's very important. Okay, so it's telling us to see out all the prime numbers less than 120. Now, we have to know what makes a prime number, and a prime number is a number that can only be divided by itself in 1. 1 technically is not considered a prime number. You can Google it and it will tell you that it is technically not a prime number, so we'll be excluding 1. 0 as well. So the way you can find the prime number is if a number other than itself can divide it evenly, then that is not a prime number. So let me show you an example. If 20 divided by 2, for example, 20 divided by 2, we get 10. That means it is not a prime number because it gives us a remainder of 0. But for example, let's say 13 divided by 2, that gives us a remainder of 0.5. So we know that it is a prime number. Well, we know that for that instance, not a prime number. We'll be able to search that through a for loop. Now, let's take 20, for example. Now, if we divide it by a number, let's say 11, if we do 20 divided by 11, that's going to give us this weird remainder. So this method only works for numbers that are less than half of whatever the number you're trying to divide. So no matter what, you're going to always only have to search that half. So let's write that for loop. So for integer I is equal to 2, we're excluding 1 and 0. I is less than num divided by 2. I plus. And this is just my prime function. I hope you catch on to that. Okay. So if the modulus of that number by the I is even, then we know that it isn't a prime number. Otherwise, it is a prime number. Otherwise, then it is. Okay, so let's write that. So now let's implement that up here. So constant int num is equal to 120, and I just did this so that I make sure that I don't somehow alter this 120 somewhere within the source code. So for integer I equal to 0, I is less than num I plus plus. I want to do if I is prime, then I want to wait. I forgot to check the stack of integers. I'm gonna call this stack.push. I'm adding. Push means I'm gonna add to a stack. Stop that. Push that. Okay. Now I wanna print out whatever is in my stack. So while my stack is not empty, while there is something in there, I want to see out whatever I have on the top of my stack. I'll pop it out. Okay, and I should probably put a see out. Yep. Let's run it. Cross our fingers. There we go. So all the prime numbers less than 120 are 113, 109, 107, 103, 101, 107. And you can look through all of these. Actually, what is giving us this? Oh, I see. Without excluding 2. I mean, we're excluding 1 and 0. Okay, there we go. And these should be the list of all the prime numbers that are less than 120. And that's how you do 10.14.